Welcome to this explainer on suppositories. I know it's a topic that can seem a little tricky for pharmacy exams, but don't you worry, we're about to break it all down so you can absolutely nail it.
So here's our game plan. We're going to start with the math, the displacement value, then we'll move on to classifying the different types of suppositories. After that, we'll get into their bases and how they're actually made. We'll finish things off with quality control and a super quick recap of everything you've got to remember.
All right, let's jump right in. We're kicking things off with a concept that is, no joke, the absolute foundation of making a good suppository, the displacement value. Okay, think about it like this. You've got a glass of water and you drop an ice cube in. The water level rises, right? The ice cube takes up space. It's the exact same idea here. The drug takes up space in the base, and the displacement value is how we figure out exactly how much space so we get the dose and the weight perfect every single time.
Now this definition, this is gold for your exams. Write it down, remember it. It's simply the amount of drug in grams that pushes aside 1 gram of the base. It's all about making sure the final dose is spot on.
I know, 6 steps looks like a lot. But trust me, it's a really logical process. Let's just walk through it with a real example, and you'll see it's not so bad. Here we go, a classic exam-style problem. We've got to find the displacement value for zinc oxide in a theobroma oil base. We know the final product is 40% drug. Let's get into it.
First things first, we need a baseline. So imagine we made these suppositories with only the base, nothing else. We're using a 1-gram mold, so 8 of them would weigh, you guessed it, 8 grams. Easy. That's our starting point.
Okay, step 2. Let's figure out how much zinc oxide is actually in our final product. The total weight is 11.74 grams, and we know it's 40% drug. So, a quick bit of math tells us we've got 4.696 grams of zinc oxide. Now for the clever part. First, let's find out how much base is in our final medicated suppositories. We just take the total weight and subtract the drug's weight, which gives us 7.044 grams of base. Then we compare that to our theoretical 8 grams from step 1. The difference, 0.956 grams, is the amount of base that was pushed out, or displaced, by the drug. And here it is, the final calculation. We take the weight of the drug, that's our 4.696 grams, and divide it by the weight of the base it displaced, which was 0.956 grams. And boom, there it is. Our displacement value is 4.912.
Whew, okay, we made it through the math. Now, let's shift gears and talk about the different kinds of suppositories. And really, it all boils down to one simple thing: location, location, location.
The classification is super straightforward. It's just based on where they're used. You've got the most common ones, rectal and vaginal, which, by the way, are also called pessaries. Then there are urethral ones, also known as bougies. And you even have less common types for the nose and ears, sometimes called ear cones.
Okay, now let's talk about the suppository bases. Think of the base as the delivery truck for the drug. It's not just holding it, it's responsible for getting it where it needs to go and releasing it at the right time.
This chart breaks it down perfectly. You've got 3 main types. First, the fatty ones, like cocoa butter. They melt at body temperature, but they can go rancid, kind of like butter left out too long. Then you have the water-soluble bases, like glycerogelatin. These dissolve in body fluids, but they're hygroscopic, meaning they love to suck up moisture from the air. And finally, you have synthetic bases. The biggest takeaway here is how they release the drug. Fatty ones melt, water-soluble ones dissolve.
So we know the what, but what about the how? How are these things actually put together? Well, there are 3 main methods.
Now, while you might hear about hand molding or compression molding, the one you absolutely need to know, the most common one by far, is pour molding. You'll also hear it called the fusion method. And honestly, it's as easy as it sounds. You just melt the base, mix in your drug, pour that mixture into the molds, and then just let it cool down and harden. That's pretty much the whole process.
And this is the key piece of equipment for the fusion method, the suppository mold. It's what allows us to get those perfectly shaped and uniform products every single time.
But hold on, we're not quite finished. After the suppositories are made, they're not ready to go just yet. They have to pass a whole bunch of quality control tests to make sure they're both safe and effective. This table lays out the most important tests. We've got the weight uniformity test to make sure every suppository has the same dose. The melting range test, well, that's to make sure it actually melts when it's supposed to. The breaking test checks that it's sturdy enough to handle. And finally, dissolution testing sees how quickly the drug gets released.
All right, that was a lot of information. So let's do a super fast recap of the absolute must-know points for your exams.
Okay, focus on these 4 things. 1. Know what displacement value is and how to calculate it. 2. Name the 3 types of bases, oleogenous, aqueous, and emulsifying. 3. Know the 3 preparation methods, especially fusion. And 4. Be able to explain the point of the main evaluation tests. Got it? You got this.
And I'll leave you with this to think about. Choosing a base isn't just a simple technical choice. Deciding between a base that melts and one that dissolves can completely change how a drug works in the body. So remember, the base isn't just a carrier, it's a key player in the whole therapeutic process.